Hello, Leiden geometry students. In this assignment, we're going to talk about areas of some simple shapes, triangles, parallelograms, rhombus, and a little tiny bit of kites. So first, let's talk about the area of a triangle. So this is a rectangle. We already know how to find the area of a rectangle. It's base times height. In this case, 4 times 10, which would give us 40. A triangle is essentially half of a rectangle. Here, I'm going to copy the rectangle, and this area of this rectangle is still base times height, still the same measure, 40, but I can split this in half. Each of these triangles is now half of the rectangle. So the formula for the area of a triangle is always half the formula for area of a rectangle. We do 1/2 base times height. In this case, half of 4 times 10 for both, and each of these would turn out to be 20. Now, it might feel like that's cheating to explain how we get the area of a triangle because I used a right triangle, but even if it's not a right triangle, if we took this triangle and made a copy of it, we can take these two triangles and turn them back into a rectangle. All you got to do is split off some parts. You get a pair of scissors, cut off the corners, and they should line up exactly perfectly in order to make a rectangle out of your triangle. So in this case, you see this pink rectangle on your screen? Its area is base times height. So the original triangle should be half the base times height. The area of a triangle is always half base times height. So here's our formula. The area of the triangle, half the base times height. You got to remember the base and the height always make a right angle with each other. Sometimes the height and the base are sides of a triangle, and sometimes they're not. Sometimes your height is inside the triangle. So for a sample problem, take a moment to find the area of this triangle. Remember, you got to use base and height have to make a right angle with each other. So our formula, 1/2 times base times height. We have to identify our base and height. In this case, it's going to be the 8 and the 15. You may have wondered to yourself, what do I do with that 17? Nothing. It's not the base or the height in this triangle. We don't use it for finding area. We would use it to find the perimeter, but not the area. So in this case, to find the area, we do 1/2 of 8 times 15, which would give us 60 square feet in this case. Okay, so a couple problems where we see the height inside the triangle. Here, we're going to find both the area and the perimeter. Let's start with area. If we're going to do our area is 1/2 times base times height, take a moment, identify your base and height, and plug them into the formula to find the area. In this case, our base and height are 8 and 12. We know that because they make a right angle. 12 is your base, and 8 is the distance to the far side of the triangle. They make a right angle with each other. Though 8 is not one of the sides of the triangle, so we won't use it for perimeter. So 1/2 of 8 times 12 should give us 48. We don't know the units, so we just say square units. Follow-up question, what's the perimeter for this triangle? Now for the perimeter, not all the numbers in that picture get added together, only the distance around the outside of the triangle. So when we find the perimeter, we're just going to do 12 plus 10 plus 10. We don't use the 8. If you had to walk around that triangle, that 8 would not affect you in any way. So just 12 plus 10 plus 10, we get 32 units, whatever the units are. All right, area of this triangle. Again, start with our area formula. So 1/2 times base times height. Take a moment, identify your base and height, plug them into the formula, and find the area. In this case, our base and height are 8 and 5. We know that they make a right angle. 5 is the distance from the bottom, even though it's not actually touching the bottom, to the farthest side of the triangle. That's our height. So 1/2 of 8 times 5 is going to give us 20 square units. The follow-up question, find the perimeter. Now remember, perimeter is just walking around the triangle. That's just the white part here. So for the perimeter, we're just going to do 12 plus 8 plus 7. If you were walking around the triangle, you would not even pay any attention to that 5 that's outside it. We just add up the sides that are in the triangle, and we get 27 units, 27 feet or inches. Okay, two of the harder problems that can come up with any shape. One of them is when you have to do the problem backwards. That's this case. In this case, I'm going to tell you the area is 24 and ask you to find the height. We know the base and the area. We want to find the height. Now, a lot of people want to do this in their head. They're like, oh, I got it. But people make a simple mistake, which is they're not sure what to do with the 1/2 when they're going backwards. So here's a recommended way to do the problem. Start with writing the formula. Area is half base times height, or half length times width. And we start plugging in the numbers that we know. 8, we can plug that in for our length or base. And then the area is going to be 24. So we'll put the 24 in for A and the 8 in for the length. Now, in this case, some people start dividing by 8 and then dividing by 2, and that's a mistake. You don't end up dividing by 2 in this case. You divide by 1/2, which is like multiplying by 2. That can be confusing, especially if you struggle a little bit with algebra. So my advice to everybody is simplify the right side first. Take 1/2 of 8 before doing anything else. What is 1/2 of 8? It's 4. So now we have a problem that's really easy to solve and people don't have to worry about making a mistake. We just divide by 4 and we're going to get 6. If you're trying to take the shortcut in your head where you take 24 divided by 8 and you get 3, the problem people have is they're not sure if they're supposed to take half of 3 or double it. In this case, we do end up doubling it. All right, this is a compound shape. How do we find the area of this thing? All right, well, break it up into shapes you know. What we can do is we can draw on a line right here, and this line makes the top part a triangle and the bottom part a rectangle. We're going to find the areas of these two parts separately and then add those areas together. The trick is going to be finding this missing height over here on the right for the triangle. Well, we can tell because on the left-hand side we have a 9, and on the right-hand side we have 14. So you can figure out how much longer the right side is, and that's the height of the triangle. Okay, so if you do this right, that missing height of the triangle is 5 inches. So we find the area of this triangle, 1/2 times base times height. This length down here is 12, so it's half of 12 times 5. We get 38 square inches for the triangle on top. On the bottom of our rectangle, we just do 9 times 12 and get 108 square inches for the area on the bottom. Find the area of the whole thing. We simply add those two together and get 138 square inches. Next, we're going to talk about areas of parallelograms. Okay, so this is a parallelogram. It's like a rectangle, but someone sat on it and it started flopping off to the side. Now, to figure out the area of a triangle, we basically figured out how a triangle is different from a rectangle. And that's the case with most shapes. The easiest way to figure out how to calculate area is to see how you change the shape to turn it into a rectangle. And then once you can see what it looks like as a rectangle, you just do base times height. For example, here's a parallelogram, and what I want to do is turn it into a rectangle so I can identify my base and height. And the way to do this is just cut off the little slanty parts on the side. So I'm going to cut the little triangle off the side, move it over to the other side. Since it's a parallelogram, it should line up exactly. Now we have a rectangle, and the area of this rectangle is just going to be base times height. We didn't take away or add anything to the parallelogram, so the area of this parallelogram is also just base times height. The trick is the height just wasn't the side of the parallelogram. So frequently our problems would look like this, where we have to be given the height inside the parallelogram. And our formula for area of a parallelogram is just base times height. You have to try to identify your base and height. Remember, they will always make a right angle with each other. That's it for parallelograms. They're pretty easy. So for example, up here on the screen, you have two problems. We want to find the area for each of these parallelograms. Again, the formula is just base times height. Okay, in the first problem, we want to do our area is just base times height. You identify them. Your base would be 20 and the height would be 8. So just 8 times 20. We get 160 square feet for that one. On the right, a little bit trickier, the base length is 7, and the height is going to be the 16. Why? Well, they make a right angle, and the 16 measures how far apart the farthest part of the parallelogram is. So we just do 7 times 16 and get 112 square centimeters. And that's basically it for a parallelogram. So the next shape and last one we're going to talk about today is a rhombus, finding the area of a rhombus. Okay, a rhombus is a little bit weird. If you don't remember rhombus, you probably called this a diamond when you were younger, but there's a difference between a diamond and a rhombus. A diamond isn't actually a geometric shape. A diamond could be a rhombus or a kite. And this is just a rhombus. All 4 sides are the same. To find the area of a rhombus, we could do it the same way as a parallelogram if we could see a base and height, but that's frequently not the case. What we use instead are the diagonals. So we have to know the diagonals in the rhombus. In this case, they're labeled D1 and D2. It doesn't matter which one's D1 or D2. It's just the 2 different diagonals. All right, to turn this into a rectangle so we can identify our base and height error, I'm going to make a second copy of this thing. And with 2 of them, it's easy to turn stuff back into a rectangle. So you can see all these triangles kind of match up, and we can put them together and turn this into one big rectangle. And once we have this rectangle, we can see that our base and height are just the diagonals. The 2 diagonals are the lengths of the base and height. So the area of this rectangle is just base times height. But the rhombus was only half of this thing. So our base and height is diagonal times diagonal, but for the rhombus, we only want half of it. So our formula for the area of a rhombus is 1/2 times diagonal, D1 and D2. It does not matter which diagonal is D1 and which diagonal is D2, but the diagonals always make a right angle and basically work as our base and height. You have to remember the diagonal goes all the way across the shape, and you're sometimes going to be only given half the diagonal. For example, these problems. The rhombus problems, the hardest part is trying to figure out what the measurements you're being given are. For example, in this first picture over here on the far left, number 3, we have our rhombus. It says so on the top. And the diagonals, and we're trying to find the lengths of the diagonals, and you might immediately wonder, is this diagonal here, has that got a length of 3, or is 3 only half of it? When you see a picture like this, if you're not sure, you should be able to ask your teacher, is that supposed to be a full diagonal or half diagonal? But when our picture looks like this, it's a half diagonal. So in this case, the diagonal lengths aren't 3 and 4, it's 6 and 8. So we're going to use 6 and 8 in our formula of 1/2 times d1 times d2. Remember, it doesn't matter which one is d1 or d2. So it becomes 1/2 of 6 times 8. That, from there, it's pretty easy. We get 24 square meters. Problem number 4 in the middle, we're shown the full lengths, and this is an easy way to tell, but sometimes it makes the picture a little crowded, that these are our full lengths of diagonals. So all you got to do is take these two measurements, throw them into our formula. And in this case, we're going to do 1/2 of 10 times 20 and get 100 square feet for it. Problem number 5 is just like number 3. It's the way sometimes they show up so that people are less confused, but sometimes it makes the picture look a little bit more crowded. What are the lengths of the diagonals? Well, the one going left to right, that's 7 and 7, so together that's 14. And the one going up and down, it's 12 and 12, so together that's 24. Those are the lengths of your diagonals. Take them, plug them into your formulas, and find the area. And in this case, we'll have 1/2 times 24 times 14, which is going to give us 168. We don't know the units, so we just say square units. And that's it. So you might want to write these formulas down someplace where you can use them. Oh, I did forget to mention, you find the area of a kite the same way you find the area of a rhombus. But these are the formulas. You may want to have them written down. It's really easy to start mixing these things up when they start showing up on tests and quizzes.